Now they are maximized.
Yeah.
Go ahead. Thank you.
Okay, thank you. So I'm doing this presentation on behalf of the DBNet group. DBNet as a concept is a project for improving the global availability of near real-time low Earth orbit data by using a collection of direct broadcast stations distributed around the world. The primary user community for this is NWP, Regional and Global Numerical Weather Prediction. We try to ensure global consistency by using common software delivered by the satellite operators, consistent with the global processes, so that the products we derive from the DBNet stations are consistent with the corresponding global data. We have standardized coding and file naming conventions, and we have a global concept for quality monitoring. The dissemination of the products from DBNet are done by the WMO information systems, so at the moment primarily the GTS. The project is coordinated by the WMO space program, and it's supported by the Coordination Group for Meteorological Satellites, CGMS. Here I'm showing you as an example the coverage we're achieving. This is the status from November 2020. We're looking at products from the ATOFS instruments, so AMSU, MHS, on board the MEDOP and the old NOAA satellites that we achieved in November 2020. You can see here from this graph already that we're using receiving stations in South America. We have the station in Cordoba in the south that Paula is going to talk more about later. We have 4 stations in Brazil, which are coordinated by INPE. And in addition, we have different stations around that are relevant to of course, to Region 4. So NOAA is operating some stations in the Caribbean. We have stations in Miami and in Marrakech on Puerto Rico. We have stations on the Easter Island and on Ascension in the Atlantic. And we have a station in Monterey, and then we have different stations in the US and in Canada. So we're covering very well both Region 3 and 4. The initial target that we wanted to achieve is to have almost global coverage, but of course, as you can see, there are geographical gaps where it's very difficult to provide receiving stations. So the global target was have 90% of the globe available on the GTS within 30 minutes. Based on the needs of the short-range weather prediction, numerical weather prediction community, we revised the latency goal to 20 minutes. So it means that within 20 minutes after the sensing from the satellite, so after the satellite observation was made, the data has to be available on the GTS. That's our global target. So you can see it's a very, very aggressive, very demanding timeliness target. But this is what is required by the numerical weather prediction models. We achieved this goal for the ATOFS instruments in 2017. But of course, since then, things have happened. New instruments have been coming on board, so we're still working on the geographical coverage. The DBNet system is composed on regional networks, which are coordinated by regional or sub-regional nodes. And globally, we're coordinating this through the DBNet Coordination Group. We have the link here to the corresponding website on the WMO web pages. The global monitoring of the products is performed by the EUMETSAT Numerical Weather Prediction Satellite Applications Facility, the NWPSAF. They provide some very nice monitoring pages with statistics about all the stations in the network. Last month, we were finally able to have a face-to-face coordination meeting, which was held at WMO in Geneva in the beginning of October. The regional networks, which are sort of grouping the stations together, we have a regional component which is organized by EUMETSAT. We have a component which is coordinated by JMA, covering the Northern Asia-Pacific region. We have the Southern Asia-Pacific region overseen by the Bureau of Meteorology. For South America, we have the Brazilian part, the Northern South American part, which is organized by INPE, and the southern part, which is organized by the Argentinian Met Service and CONE. And finally, we have the NOAA system, which is coordinated by NOAA, but primarily by SIMS at the University of Wisconsin in Madison. We have a global document which provides guidelines as to how to organize the system, which was agreed by the Commission for Basic Systems of WMO in 2016. This is just to show you an overview of what is going on inside the DBNet systems. We, of course, have the antenna systems with the acquisition of the raw data. Then we have a processing up at the stations to level 0. And then we have centralized or local processing of the level 0 data up to level 1 products. We use both. In some cases, the processing is done at the stations. In other cases, done centrally. It's all done using standardized software, AAPP for the ATOF suite of instruments, CSPP for the ATMS and CRIS instruments. We are converting all the level 1 products to buffer and are disseminating this on the GTS. And in the case of EUMETSAT, they're also being provided on the EUMETCAST satellite-based broadcast system. And all the products are made available to all NWP centers. So the instruments that we are processing at the moment, you can see here a list of the services that we intended to start to process when we set out. Infrared microwave sounding data from the ATOF suite of instruments on board MEDOP and the POST satellites, ATMS on board the NOAA 20 and SUMI NPP satellite, and the microwave infrared sounding instruments on board the Chinese FY3 satellites. Since a few years, we've started processing hyperspectral infrared sounding data from CRIS and YASI. So CRIS on board NOAA 20 and SUMI NPP, YASI on board MEDOP. And we also intend to start processing data from the HIRAS instrument on FY3. In addition, at the time we started DBNet, we also envisaged 3 additional services, one for infrared visible imaging using VIRS, AVHR, and MERSI, one for scatterometry using ASCAT, and one for microwave imagery using the microwave imagers on board the different satellites. But the three last services are still only under consideration, have been implemented, some of them partially by EUMETSAT for the EUMETSAT stations, but not in a global way around the world. These are the satellites we're producing products from. So we have bands of orbits. We have the afternoon orbit satellites, the PM orbit satellites, where we're processing data from SUMI, NPP, NOAA 20, and FY3. We have the early morning satellites, which are currently NOAA 19 and FY3E. And we have the mid-morning satellites, which are the MEDOP satellites and NOAA 18. Of course, NOAA 21 or JPSS-2 has very recently been launched, and this will, of course, enter into the configuration in the beginning of the new year. So I said this is the coverage we're achieving for the different instruments. So for ATOFs, we have almost global coverage. We can see some gaps in there. For ATMS, it's slightly less. We have a number of areas where we're not getting ATMS data from. CRIS and YASI, more or less the same. For the Chinese instruments from the vast suite of instruments on board FY3, we have quite limited coverage because at the moment it's only EUMETSAT who is processing the data operationally from FY3. So the main areas of concern in terms of coverage are Central Asia for ATMS and CRIS, Southern Pacific for CRIS and YASI, and Central and Southern Africa. So the coverage extensions we are currently working on, I'm just quoting them here from the last meeting. INPE are working on different cooperation projects regarding new stations in the Amazon area. We are looking together with Kone, but Paula is going to talk more about that, about high latitude stations in either in South America or on the Antarctic subcontinent. Météo France have a station in Cayenne in French Guiana, which is being added to the network very soon. Environment Canada are considering stations in the northern part of Canada, Inuvik and Iqaluit. Then we have Easter Island, which, as I said here, it's it is in principle available. The transmission of data from Isla de Pascua has recently been turned off for technical reasons, but it's still in the system. We are working on reintegrating China stations. China has been out of the network for a while. For Africa, we're talking about adding stations from the Sawitra project. So there will be stations in Libreville in Gabon, in Nairobi, Niamey, and Pretoria added to the system soon. And the Finnish Meteorological Service is adding a station in northern Finland. I would just like to mention, so the primary focus of DBNet is generation of level 1 products for numerical weather prediction, so for assimilation into numerical weather prediction systems. However, we're running on the stations, we're running the suite of software provided by SIMS in Madison called CSPP. And CSPP is actually also, in addition to the level 1 products for numerical weather prediction, is producing a wide range of products which are possible to use for local applications. And I've just provided for reference a list of them here. We have a range of cloud products from the VIRS instrument on board SUMI NPP and NOAA 20. We have aerosol and volcanic ash products, also derived from VIRS. A wide range of products, very useful for local applications. We have cryosphere products, so ice surface temperatures, ice concentration, ice thickness, and snow cover products. We have different land products, so land surface temperatures, land surface albedo, and fire products. We have a specialized range of sea surface temperature products, and we also have polar winds derived from the VIRS imager. And we have a range of what is called in NOAA the unique combined atmospheric product suite, NUCAPS, derived from CRISM ATMS, which is trying to derive sounding data, or which is deriving sounding data from the infrared sounders and the microwave sounders. So you have vertical moisture profile, vertical temperature profile, carbon dioxide, monoxide, methane, ozone, and radiation products. So the data from the two sounders are converted into products which are very useful for a wide range of applications that are using sounding profiles. So this is just to summarize that these products are not at the moment considered as operational products from DBNet, but they are being generated at for all the stations in the area. And we have a corresponding range of specific products from the microwave sounder ATMS, cloud liquid water, different ice products that are specific to the microwave sounding instrument. So this concludes my part, and then I would like to pass to Paula.